everyone, this is Miss Green, and I'm going to do your instructional video for this week, showing you a little bit about Pythagorean theorem and the distance formula. So the first thing I want you to notice is if we were looking at these two formulas, they both have some squared terms in them. And then, the distance formula has a square root in it. So we're going to do a few problems together, and then we're going to identify something at the end. So if we are solving for A or B, we know we are solving for A or B because it's not the one that's across in the right angle. So we can identify this one as A, this one is B, and this one is C. And I'm going to plug the values into the formula. So we have the formula is A squared plus B squared equals C squared. And we have A is 6. B we're still trying to figure out. And C is 10. Then we're going to square each of our values. So we have 36 plus B squared equals 100. Now we have to solve for B. I'm going to subtract 36. I'm going to bring it up here. So we have B squared equals 64. Then to get B alone, I need to do the opposite of squaring something, which is square rooting it. So I'm going to square root each side, and I'm going to get B is equal to 8. And that's how you solve for A or B. Next, I'm going to solve for C, which is always across from the right angle. So I know this is C. This is going to be A or B. So I'm going to have A squared plus B squared equals C squared, and I'm going to plug those numbers in. So I know A is 35 squared plus 12 squared equals C squared. And then you can use your calculator if you need it to get 35 squared is 1225 plus 144 equals C squared. When I add those two things together, I get 1369 equals C squared. And again, to get C alone, I'm going to square root each side. And the square root of 1369 is 37. So C equals 37. A few things you can identify within Pythagorean theorem is that your C is always going to be your longest side. So if you get a number here that is not larger than 35 or 12, then you did something wrong. And we can go back and double check that again. Was 8 smaller than 10? Yes. So we know we got the right answer. Going on to the distance formula. So the first thing I need to do is identify where points S and E are. So S is at 1, 2, 3, 4, 1, 2, 3, 4. So we have S at points 4, 4. And then I have point E as -3, -4. So then I need to plug in my X values and my Y values. I'm going to label this one as point number 1. And I'm going to label this one as point number 2. So I have the distance equals the square root of, I'm just going to set up my formula, and then I'm going to plug in my numbers. So my x2 value is 4, and my y2 value is also 4. If it helps, you can go in and label them x2, y2, and then you can go in here and label them as x1, y1, and then I'm going to plug in x1 over here, which is -3, and over here, y1 is -4. Then I'm going to simplify what's in the parentheses before squaring it. So 4 minus -3 is +7. And 4 minus -4 is 8. And I'm going to square them, then take the square root of them. So 7 squared is 49. 8 squared is 64. I still need to add them together. So 49 plus 64 is 113. And I get distance equals the square root of 113. I would determine that by typing it into my calculator to get a decimal value. So the distance of this line, ES, is the square root of 113, which is about 10.63. Okay? What we're going to show you on the next one is how you can use Pythagorean theorem and the distance formula. So on this one, first I'm going to do the distance formula on the right, and then I'm going to show you how you could also use Pythagorean theorem. So again, in this point, I have point Z is at 3, 3, and I have point M is at -4, -1. I'm going to identify this one as x1, y1, and I'm going to label this one is x2, y2. It doesn't really matter when you're setting it up which point you identify as point 2 and which one is point 1. So I'm going to have the distance equals the square root of x2, which is -4, minus x1 squared plus y2, -1, minus y1, 3 squared. Distance equals the square root. This is going to be -7 squared plus -4 squared. So we have 49 plus 16. Remember, our negatives are going to go away when I take a negative times a negative. And 49 plus 16 is 65. And the square root of 65 is about 8.06. Okay? If I were to use Pythagorean theorem, which should give me the same answer, I'm going to make a triangle, a right triangle, with these two lines, finding this is side A and this is side B, and my right angle is side C. I have A is 1, 2, 3, 4. I have B is 1, 2, 3, 4, 5, 6, 7. Those numbers look familiar. So I can plug it into A squared plus B squared equals C squared, where A is 4 squared, B is 7 squared, and I want to find the distance, also how long my hypotenuse is, which is C squared. 4 squared is 16, 7 squared is 49, and when I add them together, I get 65. To be able to get C alone, I square root each side, and what you can notice is C is about 8.06. I use about because it's not a perfect decimal. If you were to use an equal sign, I would want you to be able to take the square root of something like 64 to seeing that it equals 8. But because 65 is not a perfect square, I like to write about because it's really a long decimal, like 8.062257748. It may be going on past that. But if you can identify, you can see that Pythagorean theorem is going to work out the same as the distance formula, which I think is pretty awesome. Reach out to your math teacher if you have any questions, and I hope you have a good week.